In this video, we're going to start taking a look at conditional logic in Excel. Specifically, we're going to start by looking at if statements. Here we have a spreadsheet that has a bunch of employees for a company, what their gender is, the position that they hold, how old they are, and what their college GPA was, along with their current salary. We'll start off by creating a dashboard, and we'll do that by adding a new sheet here at the bottom. We'll move it to the front, and we'll name it Summary. On this summary sheet or dashboard sheet, we'll have a number of different input cells and a few output cells. Now to denote inputs, I like to use these cell styles here in the top and choose this input option. We have a few things that we need to input, and so we'll list them out together before we get started into the rest of this video. The first one is gender, the next one is age, followed by retirement age, followed by years window, and I'll explain what these mean as we go on. We'll have one for GPA, bonus percent, another one for GPA, and this time we'll have a raise percent, and a raise percent for under the GPA. This raise percent will be for over the GPA. To make these a little bit easier to see, we'll use this input style here. And what we can actually do is hold down the Control key and select each of these cells and then choose the input. That formats them all at the same time. Now there are a few of these that we want to group together. For example, this GPA and bonus percent actually belong together. And so what we'll do is we'll move them over to their own section right here. And then these three belong together as well, so we'll move them over to their own section. And what we can do to denote this a little bit more easily is we'll insert a column here, and we'll put boxes around these particular inputs. And then we can change the column width of these border columns. And we'll insert an extra column between here, just to give it a little bit more space. At the top here, we don't need that border. We can select those two cells, press Control-1 to get to the Format menu, choose Border, and we'll remove the border at the top. There we go. Now, since this is a dashboard, we'll add a title to it. And again, I like to use these cell formats here. We'll just choose Heading, and we'll call this Conditional Inputs. And we'll align that to the left. We'll move it across here, choose that same heading. We'll give that row a little bit of additional height. Delete that one beneath it. And then here we'll copy this. We can actually copy this whole row, right click, copy. And down here, we'll choose right click, insert copied cells. And now here we'll call this Conditional Outputs. And down here, we're going to have a few different outputs. One of them will be average salary. Another one will be number of employees. And then we'll have a third one that's called employees eligible to retire. Here we'll designate these cells as output cells, and then we'll resize these columns so that they fit all of the information. And we'll make them the same column width. The other thing we'll do is we'll go to the View tab and we'll turn off grid lines. So this is our summary sheet, and the rest of this video is going to be going through each of these input and output cells to determine how we can use conditional logic to generate answers to our questions. For this cell here, we'll need to choose the type of data that goes into it. In this case, it'll be male or female because it lines out to this column over here. So to do that, we can go to the data validation tool. We can choose to allow a list, and we will choose male or female. Click OK. Now we can choose those from that list. This one is age. We'll type in 40 to begin. Our retirement age is going to be 65, and the year's window for that will be 35. To start off, our GPA to determine the bonus will be a 3.5, and the bonus percent will be 10%. Our GPA for raises will be a 3.0% or a 3.0 GPA. And notice that decimal place goes away, so we'll have to manually go in here and ask it to increase it to a single decimal point. If you have over a 3.0 GPA, then your raise would be 8%. If you have under, it would be 3%. Now, to make these cells easier for us to reference as we go through the rest of this video, I'm going to name these ranges. Here I'll type in IN, short for input, and we can't use spaces in naming a cell, so we'll just call it IN gender. And then here we'll call IN underscore age. This one we'll call IN underscore R underscore age, retirement age. Here we'll call this years. This one we'll call in bonus GPA, and this one we'll call in bonus percent or PCT. Over here we'll call this in raise GPA, in raise over, and in raise under. Now, these will make it much easier for us to conduct formulas on the next sheet, this if statements sheet, because we can reference these cells without having to jump back and forth between the two sheets. The first question that we're going to answer is, what is the average salary of the employees on the list based on their gender? To do this, we're going to use an if statement. So if we come here to the salary column, you'll notice I could start by typing in an average function. I could say equals average, and then select all of these salaries. But without editing the base data, how do I look at just those that are whatever the selected gender is on the first tab? Well, one way to do that, if we just type in here average salary, would be to use an if statement. And we want to test, the very first part of an if statement is a logical test. And so we want to test whether or not the gender here in column C is equal to the gender that we have on our conditional inputs section. Now remember that we named this cell, so I don't actually have to click back and forth between the sheets. But to demonstrate, when I click on this, you'll notice it gives me the name of that cell. Now, cell names are automatically anchored, so as you drag a formula down that uses a cell name, you don't have to worry about anchoring. So on here, we're going to start by saying if the gender here in C3 is equal to the input gender right here, then I want to include the salary. If it's not, I don't want it to return anything. But I can't put a 0 here, because if I put a 0 here, it will mess up the average calculation that's going to be at the bottom. So instead, I need to be blank. And the way you do that in Excel is by doing a double quote, like this. Close parenthesis and enter. So you'll see it follows the number here because this is the same gender as our initial sheet. If I use the format painter I can get it to be the same format. And now as I drag that down, you'll see it gives me the average salary for only females. If I copy this average formula over, it's looking at that range, and now it shows me the difference between the average salary of everyone and the average salary of only the gender that I have chosen. So here on this page, I could type equals average and then choose to select this column here. Close parenthesis, enter. The number formatting needs to be updated, so we'll do that now. And since these are relatively large numbers, we can decrease the decimal point. Now, to demonstrate why a summary sheet like this is useful, here at the top, I can change the gender in this list and it automatically changes the salary that's shown below. So for example, if I flip back to this sheet here, you'll notice the blank cells are now the ones that are female and the filled in cells are the ones that are male. Remember, because in our if statement, the way that it's functioned, it first performs a logical test. If that test comes back as true, it gives me the value in the first after the first comma. And if the value comes back as false from this logical test, then it returns whatever's in this second position. Now let's answer our next question. How many employees do we have under the age that we've input here? Going back to this sheet, we can choose count age as the title of this column. And we'll again use an if statement. This time we'll say if the age is less than the input age, which remember I named that cell, then we want to include it, and if not, we don't want to count it. What I can do here, since I want a count of employees, is I can just use the number 1 to count it if it exists, and the number 0 if it does not meet the criteria. So if the age is less than 40, it will show 1, and if it's not, it will show 0. As we go here, we'll remove the bold formatting and we'll drag this all the way down. Now you can see if I use the sum function, I can add up however many numbers are here, and you'll see that there are 8 employees below that given age. So on this summary sheet then, I can just type equals the sum of this column here, close parenthesis, enter, and now you can see I have 8 employees that meet that criteria. I might want to change this title a little bit to say number of employees under, and then it would be great if it showed the age as part of this cell. And in fact, you can do that. If you type the equal sign, start off with double quotes, end with double quotes, and then use an ampersand to concatenate or combine another string of text, we can click on this text right here, hit enter, and now when I change the age to say 50, you'll notice both this count updates and the header updates. These if statements, again, are referencing onto our summary sheet to determine whether a 0 or a 1 is shown. Let's move on to our third question, which adds a little bit more complexity. And that has to do with which employees are eligible to retire. So if our retirement age is 65, and the year's window for that is 35, in this case, our year's window is telling us how far in advance do we want to understand if an employee is eligible to retire. So on this if statements sheet, we can title this retire. And we want to calculate this time, how far away are they from 65? So we'll say if the retirement age here, and again, you don't need to flip back and forth between the sheets if you remember what the names of these are, minus their current age is less than, right here, our year's window, then they would be eligible to retire. We'll put 1, and if not, we'll put 0. Close parenthesis and hit enter. What this is basically asking is this first person, administrative assistant Alice, within 35 years of retirement? And the answer is yes, she is. Now, if I drag this formula down, 35 years is a pretty long range. Let's say within 5 years of retirement. No one is within 5 years of retirement. And as we look through the list, we see that that's true. What about 10 years of retirement? Still, no one within 10 years. What about 15? Now we start to see there's one person is within 15 years of retirement. Now you may be looking at this and thinking this 50 should also be within range, but remember what we said was it has to be less than. It can't be less than or equal to in that logic. If we wanted to change the logic to say less than or equal to, and we drag that down, it now includes this plant manager at age 50. So we'll do the same type of thing that we did here with the count of ages, and we'll use the sum function. And notice that there are 2 right now that are eligible to retire. We'll use that same formula here to sum up those that are going to be eligible to retire within that number of years. Remember, this is not eligible to retire right now. It's eligible to retire within this year window. So within 15 years, we'll have 2 employees eligible to retire. Within 25 years, we'll have 7. Now, the next 2 boxes here answer questions that are not going to give outputs here on this page, but will give additional columns here on this second tab. So the first one is, what if I want to determine the bonus I give to an associate based on their GPA? Over here, I can type in a column called bonus. And in this case, I want to determine if their if their GPA is greater than or equal to what I have on this page here. So I will start with an if statement. If, and remember this was our input for the bonus GPA, if the bonus GPA is less than my current GPA, then I want to give them that input bonus percentage multiplied by their current salary. Otherwise, I want to give them 0. And I'll close parentheses and hit enter. Now notice how I flipped around the logic here. We talked about it being greater than or equal to, but by putting the bonus GPA first, I could use the less than sign, and logically it remains the same statement. Another thing that I want to point out here is that I multiplied this bonus percent within the if statement. So notice how there's a calculation that's happening inside of this value if true section. Another thing that I could do is if I delete that from inside of here and instead multiply on the outside, I still get $3,600 here, and we'll use Format Painter to keep that. And if I drag it down, those that don't meet that criteria wind up with 0, because 0 times anything is 0. So in sum, I'm going to pay out about $30,000 in bonus based on the inputs that I have currently. Now typically with dollar figures, we'll right align them so that the units line up. And now we'll answer our final question, which is if I want to now consider an annual raise based on the GPA. If your GPA is over this threshold, then I'll give you 8%. And if it's under that threshold, I'll give you 3%. So back here on this sheet, we'll call this raise. And again, we'll use this if statement. If the GPA is greater than the input of our raised GPA, then we want to return that 8%. So we'll say input raise over. Otherwise, we'll give them the input raise under amount. So as this comes through, this GPA is greater than that 3.0 cutoff. Therefore, they get an 8% raise. As I format this as a percent, remove the bold, and then drag it down, you'll see that these values follow. But what if I want to understand the raise dollars? I could do this by taking this percentage times the current salary, and that would be the amount of dollars received in a raise. Another way that I could do this, though, is by taking this same formula here, I'll just copy the entire formula, and then multiplying it by the salary. And I can do that all in one cell. What if I wanted to understand all of the total new salary and not just the raised dollars? Think about how you might do that for a moment. The way that I think it could be done is if we take this same formula here, copy it, Control C, paste it in here, and then multiply it by the salary, we get that raise amount. But if we take that raise 1 plus the amount that we're going to give them as a raise and multiply that, it now does the math to add this together, because you're saying what's 1.8%, or in other words 108% of your current salary. And that's how we calculate the new salary. So you can see through all these examples that if statements are very helpful to solving a variety of different problems. They allow you to use basic logic. In addition to a simple if statement, there are actually some easier ways to answer these average salary questions. And there are combined if formulas out there in Excel. One of them is called average ifs. And this allows you to find the average given any number of criteria. So if we want to take an average of a specific range, let's just say we want to take an average of this salary range, and we have a criteria range that we want to evaluate, let's say here, the gender. I can then choose that input gender, close the parenthesis, and calculate all of that exact same work that we did over here by adding in an entire additional column and then having to use an average formula over here that references that new column. I did all of that work here in a single formula. There are similar formulas like this for sum and for count. And I know that if you will take a moment to Google how to find the average if something or the sum if something, there will be many examples of how you can use these additional formulas to cut down the amount of time you spend creating new columns and using kind of the most basic form of an if formula. I'll conclude this video by just saying that if statements are very, very important for analysts. One of the main things that distinguishes somebody who's skilled in spreadsheets from somebody who is not skilled is the mastery of functions, and especially the if function. We'll be using this one frequently over the course of this semester, and so I would encourage you to practice it until you've got a firm grasp on it.